Hi there, folks. It's actually a bit cloudy today, and I literally just made tea. So I'm actually waiting for this to cool down as it's far too hot. I'm gonna put this aside, and I was like, well, what can I do while I wait? And I was like, well, I can actually do a video about something. And this something is going to be a little bit of complex analysis. So the reason why I'm doing this is actually because it's actually useful to have these kind of concepts when you are taking your signal and system course, like you should be doing right now. So let's start. Well, today in particular, I want to be talking about the residue of a function. So let's start, as always, with an example. Now, please note that there are mainly three different ways to find residue of a function, and it really depends on either which one you're more familiar with, but also on the function itself, because some methods cannot be applied to some functions and vice versa. So let's crack on and start with an example. So as a first example, I suppose that we want to know what's the residue of the function. I'm going to have our function, which is f of z equal to cosine of z over z to the fourth minus 1, with z0 equal to I. Well, some books actually use at z0 equal to I. It's the same. It's just a notation, literally. So what's the residue of this function at z0 equal to I? Well, first of all, we don't like this denominator, so we are gonna rewrite it. So f of z is equal to cosine of z over z to the 4 minus 1. So we said we're gonna rewrite the denominator. So f of z equal to cosine of z over, well, this one can actually be rewritten as z squared minus 1 times z squared plus 1. So we can say, okay, this is z squared minus 1 times z squared plus 1. But we're still not happy with it. How can we simplify it even further? Well, we can actually take a look and say, okay, we have z squared minus 1 on one side and z squared plus 1 on this side. We're actually interested in z squared plus 1 on this right-hand side. And if you remember, you can actually rewrite this using the property of imaginary numbers as f of z equal to cosine of z over z squared minus 1 times z plus I times z minus I. There we go. Now, where do we go from here? Well, f of z is a continuous holomorphic function at z equal to 1, because you have this one here. So I can actually say that f of z is a continuous holomorphic at z equal to 1. In fact, z equal to I is a simple pole. Is a simple pole. So we can actually use the limit. What I mean by the limit? Well, I mean that the residue of z0 equal to I is, well, the limit as z approaches I of, we're going to multiply by z minus I, so z minus I times the whole function, so cosine of z over z squared minus 1 times z squared, plus I times z minus phi, like so. Now, from here, you can say that the residue of z0 equal to I is, well, we are actually going to simplify z minus I and z minus I. You can see that it is the limit as z approaches I of cosine of z over z squared minus 1 times z plus I. Now, we are getting closer because right now we can actually substitute z with I as we have the limit. So, if we substitute that, we get that r of z0 equal to I is equal to cosine of I over negative 4i. Now, negative 4i is fine. What we don't actually like is cosine of I. But we can actually rewrite it. Because from Euler's formula, we know that e to the iz is cosine of z plus I sine of z. Now, we are interested in cosine of I. So, cosine of z plus I sine of z is equal to e to the iz. Therefore, cosine of z is equal to e to the iz minus I sine of z. And by using other properties, again, the property of the Euler formula, we can actually rewrite this finally as cosine of z equal to e to the iz plus e to the negative iz over 2. Now, if we apply this to our result, well, we get that the residue of z0 equal to I is actually e plus e to the negative 1 over 2 everything over negative 4i, where these two here are actually cosine of I. Now, going on from here, we can say that z0 equal to I is e plus e to the negative 1 over negative 8i, because you had these two and these 4. So we can take the negative sign in front of everything, and we can say that our residue of z0 equal to I is negative e plus e to the negative 1 everything over 8i. And this is our solution. Oh, almost forgot. Now it's actually time to celebrate with a cup of tea.